This video discusses about biosynthesis, metabolism, mechanism of acetylcholine. Serine, which produces choline. Then acetyl-CoA combines with choline to give acetylcholine. First, decarboxylation to give hydroxyl ethylamine. Then N-methyl transferase is involved in the transfer of methyl group from S-adenosyl methionine to produce choline. This choline on reaction with acetyl-CoA, which was produced from acetate and coenzyme A. This, in the presence of choline acetyl transferase, gives acetylcholine. So, serine decarboxylation, choline N-methyl transferase produces choline, and then acetyl-CoA combination to give acetylcholine. Acetyl-CoA combines with choline. In the presence of choline acetyl transferase, you get acetylcholine. This acetylcholine is neurotransmitter in parasympathetic nerve ending and somatic nerves. So, this is having touching the muscarinic receptor and nicotinic receptor present in the skeletal muscle. In the case of muscarinic receptor, we have the ganglion. Whereas nicotinic receptor do not have ganglionic point. The somatic nerve system has nicotinic receptor and it innervates skeletal muscle. The neurotransmitter is acetylcholine. In the autonomic system, sympathetic system, parasympathetic system, the preganglionic neurotransmitter is acetylcholine. Only in the parasympathetic smooth muscle and cardiac muscle, acetylcholine is the neurotransmitter. So, this we have to remember. All the places acetylcholine is present throughout the body. So, it cannot be given as a drug. The presynapse and postsynapse have receptors for acetylcholine, namely muscarinic in name. So, that is, it is made of 5 different subtypes. So, we have 3 M1, M3, M5 excitation receptors, whereas M2 and M4 have inhibition effect. One is auto-inhibition of release of acetylcholine, and another one is the opposite effect of excitation, that is inhibition by M4 receptor. How the muscle contraction happens, especially in the smooth muscle, cardiac muscle, with the help of acetylcholine. First, acetylcholine binds with the receptor and it activates the 7 GTP in this one, that is it releases GTP, phospholipase. phosphatidyl ionocetal biphosphate, diacyl glycerol, phosphokinase protein, and then it releases protein P, and that causes muscle contraction. So this phosphatidyl biphosphate releases ionocetal triphosphate, which interacts with endothelium reticulum and releases free calcium. That calcimodulin interaction with the muscle fibers gives muscle contraction. This is overall structure or figure of how acetylcholine is synthesized, released, degraded, stored, etc. So first one is glucose is converted to pyruvate, pyruvate is converted to acetate, and that acetate is used in the transfer of CoA, acetyl-CoA. Acetate is transferred to coenzyme A, and then this acetyl-CoA combines with choline to become acetylcholine in the presence of choline acetyl transferase. Hence, it is stored in the vesicles. Once the calcium influx happens, acetylcholine is released. Once the calcium comes in, acetylcholine is released. It binds with the receptors. The excess acetylcholine is hydrolyzed by acetylcholine esterase to become choline and acetate. This choline is again taken back. The acetylcholine is taken back. Choline is taken back. And this is the mechanism of acetylcholine and storage and release. This is the second mechanism wherein adenyl cyclase is released, and that converts cyclic AMP, that produces cyclic AMP and again releases protein P, and finally the muscle contraction. The acetylcholine binds, it activates the receptor and produces GTP GDP conversion, which activates adenyl cyclase. This is the second mechanism you have to remember. Now the effects of acetylcholine and its uses, or where and all it is involved. So this is called acetylcholine muscarinic agonists. Increases saliva, increases gastric secretion, increases the motility of GIT and urinary tract by contraction of smooth muscle, and increases the constriction of pupil. So these are the agonist action. If the drug is having similar to acetylcholine mimetic or cholinomimetic agent or a muscarinic agonist, then these are the actions produced by those drugs as well as acetylcholine. This is the mechanism of binding of acetylcholine with receptor. See this muscarinic receptor. So it is muscarinic receptor is 7 transmembrane. Okay, so this 7 transmembrane is having so many amino acids. See this: threonine, tyrosine, serine, tyrosine, and aspartame. So this aspartame interacts with this, serine interacts with this, threonine, tyrosine, threonine, and Now the receptor distribution. So the receptor distribution M1 is distributed in CNS, gastric and salivary glands and autonomic gamma and enteric nerves, and it is innervated, it is acting through GQ protein, whereas M2 receptor is GI and GO protein. It is present in nerve terminals, CNS, heart and smooth muscle. Now the M3 and M4, M5 receptor. M3, M4, M5 receptor. They are innervated by G protein of Q subtype. It is present in smooth muscles, glands and heart. CNS is the area where you can find M4 receptor, and it is GQ. So wherever you find the GQ subtype, they are M1, 3 and 5. Whereas for M2 and M4, you can see GI subtype. So this is the similarity you can find. M2 and M4 are similar, and M1, M3, M5 are similar in nature. This M5 is present in periphery muscle system or periphery organs, and they are muscarinic acetylcholine receptors. It is present in substantial nigra and ventral tegmentum area.